good evening everyone. I am Shadni Tercero and I am a Group 7 last reporter, and my assigned topic is combustion analysis, which is a continuation of Lorraine's report. So in this report, I'll be discussing the instrumentation, calculations, and determining chemical formulas, and also binary compounds. So let us now discuss about the instrumentation first. So through the instrumentation of combustion analysis has greatly improved, the basic components of the apparatus have not changed much since the late 18th century. So the picture displayed on the screen is an apparatus. It is a combustion apparatus from the 19th century. The collections in the History of Chemistry Apparatus Museum, University of Cincinnati. So the combustion analysis apparatus, it is a relatively simple device that has been used for many years to successfully determine empirical formulas. So for compounds that react with oxygen to form carbon dioxide and water. So the next slide is the sample of an organic compound such as a hydrocarbon. So hydrocarbon is an organic compound consisting entirely of hydrogen and carbon. So it is contained within a furnace or exposed to and burned in the presence of oxygen, creating water vapor and carbon dioxide gas. So combustion analysis, it is basically a popular method that is used to determine the chemical formula of certain compounds. So this is what your basic combustion analysis apparatus is gonna look like, and it consists of a furnace with your sample inside, and it is also consists of water trap. So as you can see in the illustration, there's a water trap that absorbs water, and then connected to that is another CO2 trap that absorbs CO2. So the way that this works is before nimo i-burn ang imuhang sample is imuha usang i-allow ang oxygen gas to continuously flow through the system. So this ang kaning process it is called purging the system. So you're forcing out tanang air and you have nothing left sa imong sample but oxygen. So after purging is imuha nang i-ignite imuhang sample, and this is actually accomplished by a copper wire that is connected to your sample and also to the lead of the power source. So once imuha na siyang i-turn on ang power source, that sparks up your sample, and since ang oxygen is continuously being added man siya to the system, so that allows your sample to undergo a complete combustion. And the two products of combustion are water and carbon dioxide. So ang water, it will get absorbed by your H2O absorber, and the carbon dioxide gets absorbed by your CO2 absorber. So ang idea there is ato ang i-figure out how much water and how much carbon dioxide came from our sample once ato na siyang i-allow to undergo combustion. And then once ato nang ma-find out how much water and how much carbon dioxide came from that sample, then we can start calculating now. We can calculate na how much carbon and how much hydrogen came from that sample, and we can also get kanang closer to para ma-figure out nato ang chemical formula of that compound. So as you noticed, walay hydrogen in carbon dioxide, and there's no carbon dioxide in water. So all carbon is converted to CO2 and all hydrogen is converted to H2O. And then anything else other than that, it passes through the system and it is not absorbed. Ang absorbed ra is ang water and ang carbon dioxide. So other elements is determined by subtraction. So if you have the mass of your original sample Again, since ang ma-absorb raman kay ang CO2 and ang hydrogen, so other elements is determined by subtraction. So if you have the mass of your original sample before ka nag-start sa reaction and you were able to calculate the masses of carbon and hydrogen, you can take the mass of your original sample, then imuha ra siyang i-subtract, and then that give you the mass of your other elements other than CO2. So, mao na siya ang basic combustion analysis. Now, let us proceed to calculations and determining chemical formulas. So, the following reaction takes place in combustion analysis. By the way, kanang small letters sa ubos, kanang letters A and B, gitawag na siya og subscripts. It refers to the numbers of atoms of the element. As you can remember from the previous slide, ako na-mention na ang combustion analysis is a method in determining chemical formula of certain compound. So if i-add nimo ang carbon and oxygen, ang mahimong product niya is carbon dioxide, and when molecular hydrogen and oxygen are combined and allowed to react together, so energy is released and the molecules of hydrogen and oxygen can combine to form water or hydrogen peroxide. So again, all carbon is converted to carbon dioxide or CO2, and all hydrogen is converted to H2O or water. So, mao na siya ang reaction in combustion analysis.
So, I have here an example of combustion analysis problem and including steps in solving it. So, the given problem is 1.410 grams of H2O and 4.3051 grams of carbon dioxide were produced after burning a hydrocarbon in a combustion analysis apparatus. So, separately, the molar mass of this hydrocarbon was found to be 204.35 grams per mole. So, you have to calculate the empirical and molecular formulas of this hydrocarbon. So, step 1, using the molar masses of water and carbon dioxide, determine the mole of hydrogen and carbon that were produced. So 1.410 grams of H2O times 1 mole per water or H2O over 18.15 grams of H2O times 2 mole of hydrogen over 1 mole of water. So here, given na ang value sa compound, which is ang value sa water and value sa carbon dioxide. So, ang process ani niya is isuwat nimo daan ang value sa H2O and carbon dioxide, which is naa na sa given. But first, let us mag-start lang sa taas sa water. So here we have to convert each into moles in order for us to determine the moles of hydrogen and carbon. So here 1.410 grams of H2O times 1 mole of H2O over 18.15 grams of H2O. So 1 molar mass of H2O or water is equivalent of 18.15 grams of H2O. So, ang kanang 18.15 grams of H2O is, dili na siya given ha. Mao na ang molar mass sa 1 mole of H2O. So, ma-search na ninyo siya sa Google ang kanang 1 mole of carbon, 1 mole of water, like that. So, mao na siya 1 mole of H2O. Since, dili pa man nato makuha ang moles of hydrogen, it's because kanang it is still water man, so need pa na nato siya i-convert into hydrogen since ang nasa step 1 is to determine man the mole of hydrogen and carbon. So you have to So in order for you to do that, in order for us to do that is we have to convert to moles of each element in compound. So here kay makita ninyo na ay kanang gi-multiply siya by 2 mole of hydrogen over 1 mole of H2O. So you might be asking, nganong 2 mole ang hydrogen? It's because in every 1 mole of H2O, ang equivalent na niya nga mole is 2 man. So 1 mole of H2O is equivalent of 2 mole is equivalent to 2 mole of hydrogen. So actually guys, makita na ninyo sa iyang subscripts nga ang kanang sa H2O, di ba, na ay number nga 2 sa ubos. So mao na siya ang subscript sa H2O or ang mole sa H2O. Ano naa sa ubos kana H2 and then O. So after that, since nakuha naman na to ang mole niya, now we are going to compute. So 1.410 grams divided by 18.15 grams. Ang answer na niya is 0.07826 and then i-multiply na to siya by 2. So the final answer is 0.1565 mole of hydrogen. So nakuha na nato ang mole of hydrogen. So now let us move to determining the mole of carbon since man naman ang hydrogen. So again guys, just remember na ang kanang 1 mole of H2O is dili na siya given. Ang kanang 1 mole niya which is ang 18.15 grams. So ato ara na siyang i-search ang ilahang mole. So now let us proceed to determining the carbon. So actually guys, same ra gyapon na ang process niya guys sa pag-solve na to dito sa sa pag-determine na to sa mole sa hydrogen. So 4.3051 grams of carbon dioxide times 1 mole of carbon dioxide over 44.10 grams of carbon dioxide. So again, ang kanang 1 mole of again need na to siya i-convert to 1 mole. So ang mole sa 1 mole of carbon dioxide is 44.10 grams of carbon dioxide. So again, since ang value sa 1 mole of carbon dioxide is 1 raman. So ang imong ibutan dira is 1 mole of carbon. Since 1 naman ang value sa 1 mole of carbon dioxide. So atoan na siyang i-compute. So 4.3051 grams divided by 44.10 grams. Ang answer niya, ang final answer niya is 0.09782 mole of carbon. So now that nakuha na nato ang value sa ang mole sa carbon, let us proceed to the second step.
So for the second step, we have to divide the larger molar amount by the smaller amount. In some cases, the ratio is not made up of two integers. Convert the numerator of the ratio to an improper fraction, and then rewrite the ratio in whole numbers as shown. So, diba, sa first step is ato i-determine ang moles of hydrogen and carbon. So, sa hydrogen, ang iyang moles is 0.1565 and ang moles sa carbon is 0.09782. So, imuhang i-divide ang larger molar amount which is 0.1565 by the smaller amount which is 0.09782 moles of carbon. So 1.600 moles of hydrogen over 1 mole of carbon. So mao na ang iyahang answer. Since the ratio is not made up of two integers man and need na to siya i-convert. Need to siya i-convert guys. Ato siya i-convert to an improper fraction. Because the answer should be kanang a whole number man. So diri nga part is medyo hassle siya because you have to because as you convert it to an improper fraction man, you need to figure out the greatest common factor niya. So, to convert 1.600 to fraction, so ang decimal point, i-divide by 1, and then we need to multiply both the numerator and denominator by 10 para wala na decimal point. So, that would be 16 over 10, 16 divided by 10 hydrogen over 1 mole of carbon. Since dapat man whole number, so, dapat whole number ang ato ang answer, so, ato gihapon pangitaon ang iyang GCF or greatest common factor, which is 2. So, ato ang i-divide ang 16 over 10 by 2. So, 16 divided by 2, that would be 8. And 10 divided by 2 is 5. So, since whole number naman siya, ang 8 ug ang 5, whole number naman siya, so no need na nato siya i-simplify into its lowest form. So that would be our empirical formula, C5H8. So take note guys na ang empirical formula, take note for that kanang empirical formula because sa next slide atuan ang pangitaon iyang empirical weight. Okay. So sa next slide is ako nang gikuha daan ang empirical weight. So just remember guys na ingana ang process sa pagkuha sa empirical weight. So we have to find the molar mass of the empirical weight first. So we have 68.114. So that would be our empirical formula weight. Now, which is ato ang gamiton sa for the third and the last step sa pag-calculate ani nga problem. So the third and the last step is to get the molecular formula. So divide the experimental molar mass of the unknown hydrocarbon by the empirical weight. So guys, ang kanang molar mass is given na siya. Ang ato ang pangitaon na lang is ang iyahang empirical formula weight. Since ako naman tong gipakita niyo ganiha sa previous slide, which is the empirical formula weight is 68.114. So therefore we need to so the molar mass of 204.35 grams per mole divided by the empirical formula, we have 68.114 grams per mole. So that's equal to 3. So therefore, we need to multiply the subscripts of the empirical formula by 3. So C5 times 3 is 15. And 8 times 3, that would be 24. So the formula is C15H24. So, excuse me. So that's the molecular formula and that's the final answer to this problem. So now guys that now you know how to find the empirical formula and the molecular formula if you're given the grams of all the elements in the compound. So again, our molecular formula is C15H24 because ato man gi-multiply siya by 3. So I have here another example, same ra gihapon ang iyang process. So here we are given tanang grams of the elements in the compound. So a compound of 20.32 grams of carbon, excuse me, 5.12 grams of hydrogen, and 7.9 grams of nitrogen. A. What is the empirical formula? And letter B. What is the molecular formula if the molar mass of the compound is 236.448 grams per mole? So guys, we're gonna follow the same steps of converting each into moles. So 20.32 grams of carbon over 1 times the molar mass of carbon is a molar mass of carbon is 12.01 grams for every 1 mole of carbon. 20 0.32 divided by 12.01, so that's 1.692. Next is hydrogen. So 5.12 grams of hydrogen. The molar mass is 1.008 grams of hydrogen for 1 mole. That's 5.079. And finally, we have the nitrogen, 7.9 grams of nitrogen. The molar mass is 14.01 grams for every 1 mole of nitrogen. So this will give us 0.5639 moles of nitrogen. So now, same process ra gihapon siya guys. Need na to siya i-divide each number by the smallest of those three values. So the smallest value is 0.5639. So we have 1.692 divided by the smallest value, which is 0.5639. So that is 3. Next is 5.079 divided by 0.5639. So we have 9. And lastly, 0.539, kana i-divide din mo siya by itself. This will give us 1. So the empirical formula for this problem is C3H9 N1, or simply just N. So again, mao na siya atong empirical formula. Dali ra na to siya nakuha since whole number naman siya, and whole number naman ang ato ang answer, so no need na nato siya simplify into its lowest form. Now let us find the molecular formula for C3H9N. So we have to find the molar mass of the empirical formula, or empirical formula weight. So natay 3 carbon of atoms, 9 hydrogen, and 1 nitrogen of atom. So 3 so we have 3 times 12.01 plus 9.9 times 1.008 plus 14.01. So if ato siya i-compute, that's equal to 59.112. So muna siyang molar mass of the empirical formula, or empirical formula weight. So now let's find out the molecular formula for that. Corresponds to 236.448 grams per mole. So again, ato ara gihapon siyang i-divide ang molar mass by the empirical formula weight. So we have 236.448 divided by 59.112, that's equal to 4. So therefore, ato ara sad i-multiply ang subscripts to 4. So 3 times 4 is 12, 9 times 4 is 36, and lastly 1 times 4 is 4, since wala may subscript since 1 naman ang subscript sa nitrogen. So we have 4. So we have C12, H36, and 4. And that's the molecular formula for this problem.
So the last subtopic I'll discuss about would be binary compounds. So binary compounds are compounds that were made from 2 different elements. For example, H2O, HCl, CO2, etc. So by using combustion analysis, the chemical formula of a binary compound containing oxygen can also be determined. So this is particularly helpful in the case of combustion of a metal, which can result in potential oxides of multiple oxidation states.
So I have here a problem example wherein i-determine mo ang chemical formula of the oxide product in the oxidation state of iron. So a sample of iron weighing 1.7480 grams is combusted in the presence of excess oxygen. A metal oxide is formed with a mass of 2.4982 grams. So determine the chemical formula of the oxide product and the oxidation state of Fe, or iron.
So step 1, subtract the mass of iron from the mass of the oxide to determine the mass of oxygen in the product. So we have 2.4982 grams of iron oxide subtracted by 1.74880 grams of iron. So that will give us 0.7502 grams of oxygen. So the next step, by the way, ang kaning iron oxide is and iron, and from the mass of the oxide to the mass of the oxygen in the product, kana sila is actually given na siya. Step 2, using the molar masses of iron and oxygen, calculate the molar amounts of each element. So actually guys, same ra gyapon na sila og process sa katong previous example na ako ang gihatag. So 1.7480 grams of iron times 1 mole of iron. So 55.845 grams of iron is in every, so there is 55.845 grams of iron in every 1 mole of iron. So 1.7480 grams of iron divided by 55.845 grams of iron, that is 0.031301 mole of iron. And then ang results sa katong gisubtract nito nga 2.4982 by 1.780 is 0.502 grams of oxygen. So there is 16 grams of oxygen for every 1 mole of oxygen. So if we divide that to na siya, that will give us 0.04689 mole of oxygen. Step 3, divide the larger molar amount with the smaller molar amount. In some cases, the ratio is not made up of two integers. Convert the numerator of the ratio to an improper fraction and rewrite the ratio in whole numbers as shown. So we have 0.031301 mole of iron over 0.04689 mole of oxygen is equal to 0.665 mole of iron over 1 mole of oxygen. So 1 mole of oxygen is because i-divide naman na to ang 0.04689 by itself. And ang 0.031301 is divided by 0.04689, so that will give us 0.6675 mole of iron. So again guys, we have to, since our answer is not whole number, so we have to convert it into fraction. So we have to look for the greatest common factor, which is the 2 over 3 mole of iron over 1 mole of oxygen. So our final answer would be Fe2O3, and F and iron has a 3 plus oxidation state. Therefore, the chemical formula of the oxide is Fe2O3 and and iron has a 3 plus oxidation state.
So this is the iron oxide structure, Fe2O3. So the oxidation state of iron oxide is +3. Actually guys, naapa na siya process giun sa pagkuha ang iyahang oxidation number, but wala na nako na-appeal. So that would be all for my part. Thank you guys. I hope you learned something from my report. Thank you guys for watching.